In the previous video, I introduced you to the concept of azeotropes. And so an azeotrope occurs when, in a phase diagram, the liquid mole fraction of a species is equal to the vapor mole fraction. Okay? And so that's just one of the signs of having an azeotrope. But in general, understanding when and where azeotropes occur is important if you're trying to do some sort of separation of two chemical species in a mixture. And so, for example, if you're trying to purify a mixture by essentially by distillation, the azeotrope is going to be your upper limit for the highest purity you could get of a particular species. So the azeotrope represents upper maximum limit of purity. And so the idea is this. As you'll see in your separations course, in a distillation, essentially what you do is you repeatedly boil and condense a chemical species over and over again at different stages in a column. And so essentially you would proceed in a fashion like this, where you would start at some point at some mole fraction x1 here. You would boil your boil the mixture, and then you would condense it. And so you would repeatedly kind of proceed in these sorts of steps along the phase diagram. But if you have an azeotrope in your mixture, essentially the azeotrope, if you keep trying to go in these steps, when x is equal to y, there's going to be no more possibility to improve or change the mole fraction of your species. Okay? And so, essentially, if you're trying to reach a very high purity, so somewhere in here, but you had an azeotrope formation at a lower purity in the phase diagram, that means that you wouldn't be able to get to that high purity that you want. Okay? Now you'll learn, and once again, you'll learn more about that in your separations course. We won't look at it here in this thermal course. But essentially what we want to focus on, or just as motivation, I'll say that azeotropes are something that you heavily need to consider whenever you're designing a distillation column at a chemical refinery. And so if you're very concerned about azeotropes forming in your mixture, then it's going to be very important to have some sort of quantitative framework for analyzing and predicting the formation of azeotropes. Azeotrope formations. Okay? And so what we're going to do is we're going to go through the math that's involved in order to estimate the when and where an azeotrope will form.